Scientists just discovered how giant dinosaurs grew necks so massive they changed the way they walked.
A new study is giving scientists fresh insight into how some of the largest animals ever to walk the Earth quite literally shifted their weight over millions of years. Researchers at the University of Liverpool say sauropod dinosaurs, the long-necked giants made famous by species like Diplodocus and Argentinosaurus, underwent a dramatic evolutionary transformation, changing from relatively small, tail-heavy animals into massive, front-loaded quadrupeds with extraordinarily long necks. The findings, published in the journal Royal Society Open Science, help explain how sauropods developed one of the most extreme body plans in the history of life. From bipedal beginnings to giant quadrupeds. According to the research team, early ancestors of sauropods looked very different from the giants we recognize today. These early dinosaurs were much smaller, walked primarily on two legs, and relied on long, heavy tails to maintain balance. Their bodies were compact, with narrow chests and relatively short forelimbs. This meant most of their body mass was concentrated near the hips, an ideal setup for bipedal movement. Dr. Carl Bates, lead author of the study and a researcher in musculoskeletal biology at the University of Liverpool, explains that this tail-heavy build was crucial for early sauropods' upright posture. But that balance wouldn't last. The necks that changed everything. Using detailed 3D computer models, the researchers traced how sauropod body shapes changed across evolutionary time. What they found was a clear and consistent trend. Sauropods began developing broader chests, longer forelimbs, and most dramatically, much longer necks. These necks didn't just grow longer, they grew faster than the rest of the body. As neck size increased, weight gradually shifted away from the tail and toward the front of the animal. That change forced a major rethink how these dinosaurs moved. Eventually, the models show, sauropods could no longer support their weight on just two legs. Fully quadrupedal giants like the Diplodocus emerged relying on all four pillar-like limbs to support their enormous mass. In short, the iconic sauropod stance wasn't a starting point. It was the result of millions of years of evolutionary fine-tuning. Titanosaurs taking size to the extreme. The trend didn't stop there. During the Cretaceous period, earlier sauropod groups began to disappear, replaced by a new and even more extreme lineage, the Titanosaurs. This group included some of the largest land animals ever known, such as Argentinosaurus and Dreadnoughtus. According to the study, Titanosaurs pushed the sauropod body plan to their absolute limits. Their necks reached unprecedented lengths, shifting their center of mass even farther forward. As a result of devising these models, Dr. Bates said we were able to ascertain that the relative size of sauropods' necks increased gradually over time, leading to animals that were increasingly more front-heavy relative to their ancestors. Dr. Philip Mannion of Imperial College London, a co-author of the study, believes these changes may explain why titanosaurs were so successful. He said these innovations in body shape might have been key to the success of titanosaurs, noting that they were the only sauropod group to survive all the way to the end Cretaceous mass extinction 66 million years ago. Reconstructing giants with incomplete evidence. Of course, reconstructing animals that vanished tens of millions of years ago comes with challenges. While fossilized bones provide a strong framework, soft tissues, muscle, fat, and internal organs are rarely preserved. To address this uncertainty, the researchers built multiple versions of each dinosaur, ranging from extremely lean to heavily built. Even with those wide variations, the results were remarkably consistent. No matter how much extra mass was added, the evolutionary trend toward longer necks and front-heavy bodies remained clear. Dr. Vivian Allen of the Royal Veterinary College London, another member of the research team, emphasized the importance of acknowledging those uncertainties. He said there is a very high degree of uncertainty about exactly how these animals were put together. While we have good skeletons for many of them, it's difficult to be sure how much meat there was around each of the bones. A clear pattern emerges. Despite the unknowns, the takeaway from the study is unmistakable. Over time, sauropod dinosaurs evolved longer necks, broader chests, and stronger forelimbs, reshaping their bodies and fundamentally changing how they moved and lived. What began as relatively small, tail-balanced bipeds ultimately became the towering, four-legged giants that continue to capture the public imagination today. For scientists, the study fills a long-standing gap in understanding how such an extreme body plan evolved. For the rest of us, it's another reminder that even the most iconic creatures of the past didn't start out that way. They became legends, step by step, bone by bone, and pound by pound.